All right, guys, let's go over this bell work. What did we say our first step was on both of these problems? Distribute. First thing we're going to do is distribute. Do I have anything that I need to distribute up here? No. When do we use the distributive property? When we've got parentheses there. Second question before I actually go through and distribute. What am I distributing? -4. There is a subtraction sign in front of the 4. So when I'm distributing, I have to remember to take that with. Since I'm not distributing anything to the front here, I have 2x squared plus 3x. Those just come straight down. Makai, help me out. Also, put that away for me, please. When I distribute -4 to these parentheses, what do I get? -4x. Not yet. We'll combine in a minute. What do I get when I distribute to the back part? I want to know when I distribute to the entire set of parentheses. -28 or -28, absolutely. So I have -4x minus 28. That takes care of my distribution step. What did we say our second step was then? Combine like terms. How do I know if something is a like term? Make sure that's put away for me, sir. How do I know if something is a like term?
They both have the same
Same variables, same letters. How else? Same exponents. Same variables and same exponents. If it doesn't meet both of those criteria, then they are not like terms. So I want you to look at the first term with me. 2x squared. Is there anything that comes after that that would be a like term for 2x squared? No. Is there anything else that has an x in it?
Yeah.
But it also has to be squared. It has to be x squared. There are no other x squareds, so that 2x squared just comes straight down. I come to my next term, 3x. Is there a like term for 3x? -4x. I'm going to put those two together. I'm going to combine them. If I have 3x's and then I minus 4x's from it, what do I have? -1x. You can write -1x, or you can just write minus x. Remember, if there's not a number in front of the variable, there is one of them. Have I hit every single term here? Have I hit every single term here? Nope. -28. Does it have a like term? Nope. That is my constant because it does not have a variable with it. 2x squared minus x minus 28 is my fully simplified expression. Guys, as I walked around and I was answering questions or checking on work, one of the things that I saw a lot of was people were starting to include things that were not part of the original problem. There is a symbol that this original problem does not have that I saw a lot of people add on at the end. What do you think I saw? What symbol? Equal sign. A lot of people were adding an equal sign and then continuing to roll on. If there is not an equal sign in the original problem, you can't just tack it on. If it says simplify, is that the same thing as solving? No. Solving would mean I want to find x, and I have to find an equal sign in that case. Here it just said to simplify, so we're stopping right here. So far, so good with that? All right. Nevaeh, this is where we are. We're still in the bell work. Number 2. Same 2 steps as before. What do I do first? Distribute. What am I distributing?
4y.
4y. Positive or negative 4y? Positive 4y. How many terms do I need to distribute it to? You're correct. 2 terms. Michael, what do I get when I distribute to those 2 terms back there?
I got 4y and negative 8xy. I don't know.
So close. Who can tell me the only thing that's missing from Michael's distribution? Yes, sir.
4y squared.
4y squared. Why is it y squared?
Because you distributing a y to another y. That squares.
That squares it. When we multiply and it's the same variable, our exponents change. When we add and subtract, the exponents don't change, just the coefficients change, just the numbers out front. Is that a positive or a negative 4y squared? Positive. Why? Because the 4y out in front was positive. So why is it a minus 8xy? Put that away for me, sir. Because the negative right here, when I take a positive and I multiply it to a negative, I get a negative result. What do I do with these pieces up here? Leave them alone, bring them down. So I have 3xy plus 2x minus 7y squared. Put a box around and I'm done? No. What do I need to do?
My name. 3xy. Add that to negative 8xy.
3xy, we're going to combine that together with the negative 8xy. It has the same variables, the same letters, and each of those variables, each of those letters, has the same exponent. Quick question before we actually combine these. What is the exponent on the x and the exponent on the y? Those are 1s. Just like with coefficients, if it's an exponent of 1, I won't see a number written there. It's going to be important later on in our lesson, so hold that in your mind. 3xy's, and I'm going to take away 8xy's. So how many xy's do I have? Negative 5xy. Bring down the 2x. Why am I bringing down that 2x? I like it. There is no like term for that one. There's nothing else up here that just has an x to the first power. Do I have anything else that I could potentially combine together? Negative 7y squared together with? Plus 4y squared. If I take negative 7y squareds and I put it together with 4y squareds, how many y squareds do I have? Negative 3y squared. Thank you, guys. Can I do any more with that? No. How many terms does my fully simplified answer have?
I got a question.
3 terms. Yes, sir.
Does it matter the order you put it in?
Good question. Does it matter the order? Technical answer, if all they said to do was simplify with no further directions, no. What does matter is the sign in front with your coefficient. So if you have this term right here, further back it needs to be minus 5xy. The sign isn't going to change if you change the order. So this 2x, if it's in the front, it should still be a positive 2x. 3y squared should always be a negative 3y squared, so it always needs that minus with it. Yes, sir?
Does it matter which you call it? Like if the x and y are switched, so it's yx.
Good question, guys. Did you hear Jaden's question?
No.
He asked on this term right here, on what I have as the first term, where it's negative 5xy, he said, does it matter if I switch the x and the y? So it said negative 5yx. Here's my question back to see if you guys can answer this. If I tell you to multiply 5 and 2 on your calculator, does it matter which one you put in first? If you do 5 times 2 or 2 times 5? No. What operation is happening here between the 5 and the x, between the x and the y? Multiplication. So does the order matter there? No. Now, Convention says that we put it in alphabetical order. So conventionally, think of this as proper math grammar, we want it in ABC order. But is it wrong if you switch those two around? No, it's not wrong. It's just kind of like when somebody says a sentence and you're like, that's a little weird, but I know what you mean. Does that make sense? Okay. Same kind of thing when we're talking about the order that we write these terms down in. If we have just one variable, like this one up here, we want to write it in decreasing order by power, by exponent. It would not be wrong to write this one as negative 28 plus 2x squared minus x. But it just sounds a little funny to a mathematician. It's like bad grammar, but it's not incorrect. Does that make sense? Cool. We're going to use these skills as part of our lesson today. Grab your books for me if you haven't already and open them up to page 233. Yes, ma'am. Our lesson is actually fairly short today. When we get to the end of that, I'll write you a pass to go look for your jacket. Okay? Page 233. 233. What have we been talking about? Ibrahim, dear. Again. Shoop. There we go. 233. What have we been talking about in this whole unit since coming back from break? Starts with a P, and it's up there on the screen. Polynomials. We've talked about monomials quite a bit. How many terms does a monomial have? One. Just one term. In order for it to be considered a monomial, in addition to it having just one term, that term, if it has a variable, that variable cannot be underneath a radical. It can't be under a root. And if it has an exponent written down, that exponent cannot be a negative. If it has a radical, or you see a negative number up where the exponent goes, it is not a monomial. So far, so good? We'll look at some examples here in a moment. We'll clarify. A polynomial, what does that prefix poly mean? P-O-L-Y? A lot of them, multiple of them. A polynomial can be a monomial where it has just one term, or it can be the sum of two or more monomials. It can have more than one term. Binomials. What does that prefix of bi mean? Two. A binomial has the sum of two monomials. It has two terms. What about a trinomial? What's that prefix of tri mean? T-R-I? Three. A trinomial would then have three terms, or it is the sum of three monomials. The degree of a polynomial is the greatest degree of any term in the polynomial. If we have this in just one variable, it's going to be the biggest of all the exponents. Let me add that little disclaimer. In one variable. If we have more than one variable going on, we'll look at that in our first example, and I'll show you how to find the degree if it is in more than one variable. Put that away for me, sir. You got to take the earbuds out and put it up. Polynomials can be added or subtracted. We just did this in the bell work. We performed the operations indicated. We distributed if we needed to. And then we combined like terms together. If I do a sum or a difference of polynomials, it's going to have the exact same variables. If I am adding or subtracting, the variables will not change. What else will not change? It's written up there. Not only do my variables stay the same, what else stays the same? My exponents stay the same. Variables and exponents stay the same. Which means if I'm adding and subtracting, what's the only thing that can change? It's also written up there. If I am adding and subtracting, what's the only thing that can change? My coefficients. What are coefficients? The number beside my variable, the numbers in front of my variables. Those are allowed to change. The letters can't change. The powers can't change. So far, so good? You guys ready to look at a couple examples with me? We're going to do 3 examples today. First example for us, page 233. Page 233. So I'm still on the same page. We're just further down that page. My monomials. I'll give myself some room to write this. Remember, polynomials are made up of monomials. Each term needs to be a monomial in order for it to be a polynomial, because poly means what again? Multiple. More than one. In this case, we can have one or more than one for a polynomial. Monomials can only have positive whole numbers as exponents, which means no roots, no radicals. Because we've talked about this before, but it's been a minute. If I have a root or a radical, that means I have a fraction as my exponent. Are fractions whole numbers usually? No. Look at this first example with me, example A. They said it is not a polynomial. Give me the reason why this is not a polynomial. Which one breaks it? Technically, is that a square root? No, do you see that little 3 right there?
Yeah.
This guy is a cubed root, but you were good to look for that radical. That radical is what's breaking it. This is a term, but it is not a monomial. So the cubed root of x is not a monomial. That means the whole thing is not a polynomial because that's included as a term here. Makai, you got to put that away for me, dear. Not until we're done. What about example B? Is that a polynomial? Yes. Do we have any negative exponents? Are there any variables underneath radicals? No. Then it counts as a polynomial. Is it in one variable? How many variables do we have going on? 2 variables. This is a polynomial in 2 variables. Ibrahim, you're going to help me out here in just a second, okay? You ready? Yes. You're the only Ibrahim in the room. All right. We have a polynomial in 2 variables here. Which means that each and every term here is a what? Right here. Each and every term here is what? Look at what we said up above. We said this one was not a polynomial because why? Because this one was not a monomial. So why is this one a polynomial? Each of them is a monomial, absolutely correct. Each term is a monomial. All right, so the directions up here said that if it is a polynomial, B is a polynomial, then we need to state the degree of the polynomial. If it's in just one variable, that means I just look for the biggest exponent. Is this one in one variable? No. We have 2 variables going on. So let's look at each term. We're going to find the degree of each term, and the degree of my whole polynomial will be the degree of the term with the biggest degree. You ready, Michael? All right. First term up here. I want to find the degree of my first term. So I'm going to add all the exponents that I see on variables. 5, yes. Where did you get the other number from? I didn't see it. B has an exponent of 1. If I don't see it, it's a 1. So we take the 4 and the 1 and we add it together. This is degree 5. The other one is 9. Absolutely correct, sir. This one right here, we have 2 plus 7. So the degree is 9. Trent, help me out. How many letters does this very last term have? How many variables? None. What would the degree be if there are no variables? Remember here, what'd you say? 0. Absolutely correct. This guy right here is degree. Make a note in your book, please. Degree 0. There are no variables. So if I want to know the degree of the whole polynomial, I want the degree of the biggest monomial. What's the biggest degree of any of those monomials up there? 7 is my biggest degree? 9, because remember I had to add those powers together to get the degree of the monomial.
Wait, wouldn't it be 7 because the 9 is a negative?
Well, huh?
I said, wouldn't it be 7 because the 9 is a negative?
I think you're misunderstanding where we're getting the 9 from. This one is degree 0. This is not where my degree for my polynomial is coming from. This one, I added those powers together and I got a degree 9. So I think that's what you were looking at to make that mistake, but I also want to bring up something else that you saw there. Guys, this is a really important point, so please look up here if you're not already looking up here. When I'm talking about the degree and that it has to be a positive whole number, I'm talking about the exponents. I am not talking about the symbol in front of my coefficient. It would not matter if that was a minus 3 a squared b to the 7th. My powers are the things that have to be positive. Does that make sense? Okay. So far, so good? All right, last one. Ian, this one's coming to you, sir. Part C. The directions say, or not the directions, your book says that it is not a polynomial. Why? Because the exponents are negative. Yes, ma'am. The degree of this monomial, we added those powers together. Do you remember doing that? That's where that came from. All right. So I'm going to try to clarify there, and then Ian gave the answer to the second one. So I'm going to do this clarification first, and then we're going to write down the answer to part C. It is degree 9 because 2 plus 7 gives me 9, and that is bigger than when I did 4 plus 1 to get the 5. 9 is bigger than 5. All right, down here, Ian said this was not a polynomial because the exponents were negative. Which means that neither of these terms are what? Neither of them are monomials. Thank you, sir. So 2 questions before we go on to the next example. How do I know if something is a monomial? Exponents have to be positive and no roots, no radicals, no variables under a root or a radical. Yes. So it has to meet those 2 criteria. If I have a polynomial, so every single term is a monomial. Head up for me, sir. Every single term is a monomial. How do I find the degree of the whole polynomial. How do I find the degree? Elena, you've got an idea. Speak up. Okay, we're going to pass here. How do we know the degree of a monomial?
I think Mike said he knows.
You add the exponents together. If it has more than one variable, you have to add the exponents together. So here we had two different places where we added the exponents together. How do we know that the degree of the whole thing was 9 and not 5? Has to be the biggest one. Biggest degree is the degree of my polynomial. So far, so good? All right, we're going to practice adding and subtracting, which we kind of did on your bell work. So go ahead and flip the page for me. Page 234. 234. Our last two examples are here on this page, and then we're going to have time for homework. There should be absolutely no reason why you have to work on any of the homework at home for this section. We got plenty of time. So there's two different ways you can go about adding your polynomials together. You pick the way that works best for you, and then practice it that way until you are comfortable with it and you can get the same answer, the correct answer every time. We can add them horizontally. We're going to group and combine our like terms together. So if I look at my first polynomial, it has a 6x cubed. Is there an x cubed, a like term, in the other polynomial?
Yeah.
Yes. We have a 6x cubed here. How many x cubes do I have in the other polynomial? Just one. So I add the 6x cubed and the 1x cubed together. How many x cubes do we have total? 7. I have 7 x cubes here. Remember, if there is no coefficient in front of your variable, it is assumed to be a 1. In my very first polynomial here, we already dealt with the first term. What's the second term? 7x squared. Does it have a like term in the next polynomial?
Yeah,
Negative 4x squared. So we're going to group those together. I've got a positive 7 and a negative 4. What do I get when I combine 7 and negative 4 together? 3x squared. It's just 7 minus 4. Whenever we combine, guys, that means we're like adding and subtracting things. We never mean multiply or divide if I just say combine our terms. It's just kind of like I put them. Who's going trick-or-treating tonight? When you combine your candy together, you dump it out in a big pile and you just got it all there and you just count all the pieces up. If I'm going to put my like terms together, I got all my Reese cups in a pile. I got all my Kit Kats in a pile. I got all my suckers in a pile, and I'm going to count how many I've got. Does anybody else participate in the great candy exchange with their siblings? My brother and I used to sit down on the floor after we would go trick-or-treating. He'd be far enough away from me that when we dumped our buckets, our candies didn't mix. We'd dump our candy out on the floor, and we'd sort it into piles, and then we'd start trading. And then I would combine all of my like pieces together. That's what we're doing with our polynomials here.
That was a good example.
Thank you. I'm rather proud of it myself. All right. What's my next term? Negative 2x. Does it have a like term in the other polynomial? Negative 8x. When I take those two and I put them together, negative 2 together with negative 8, how much do I have all together? Negative 10. So minus 10x. Are there any other terms that I need to combine together? The 5 and the 1, those are called my constants because they don't have any variables with them. 5 and the 1, when I combine those together, it combines to give me what? 6. So that's the horizontal method. We're going to group our like terms together. I usually don't do this when I'm doing it on my own, but I will do things like put squares around my like terms, put circles around other terms that are alike that I want to join together, and then I combine them and I write my answer down here. The other method that you could use is doing it vertically. Like if you're adding a double-digit number or a triple-digit number, you want to make sure to line up your like terms and then add them together. So you would be combining 6x cubed and 1x cubed to get 7x cubed. You would combine a positive 7 and a negative 4 to get positive 3x squared. You would combine negative 2x and negative 8x to get negative 10x. And then finally you would combine 5 and 1 to get 6. So far so good? All right. Horizontal method or vertical, I don't care which one you choose. Just pick the one that you like the best and practice with that until you feel very confident using that method. One more example, and then you guys have the remainder of the time today for homework, and I'll be happy to answer homework questions. Look down the page, example number 3. You with me, sir? Yes. All right, go ahead and sit up for me so you can do this example with us. Yes, sir. Let's finish up our examples first, okay? Am I adding this time? Now I'm subtracting. So how is the process of adding and subtracting different? Think about the bell work. Signs change in both polynomials? Just the one that comes after my subtraction symbol here. We are going to distribute this subtraction to every single term that comes after it. So what happens when I distribute a negative to 5x to the 4th? Yep, I get a negative or a minus 5x to the 4th. When I distribute that negative to 9x cubed, I get minus 9x cubed. Why is this next one a plus? Negative distributed to a negative. It started off as a negative, and then when I distribute another negative to it, that gives me that positive. And then when I distribute to the 4, I get a minus 4. Are you good with that, Jaden? Okay. Let's see, Taylor, do we have a like term for 5x to the 5th? No. So I'm just going to bring that straight down. It was a term in my first polynomial. It didn't have a like term, so it comes straight down. That is my first term in my final answer. Shadrach. Next thing I see here is 11x to the 4th in my first polynomial. Does that have a like term in the other polynomial?
Yeah.
What is it? What is the like term? 2? I don't see a 2.
No, 11.
I have 11x to the 4th. Where's the like term that I can combine it with? No. I'm staying in the same line. Remember, we're doing it horizontally. So look further to the right and see if you see anything else that would be a like term. Same letter, same exponent. Yes. Is that a minus 5x to the 4th or plus?
Plus. Minus.
Minus. Okay, so I have 11x to the 4th minus 5x to the 4th. So how many of those do I have now when I combine them together? 11 minus 5?
11 minus 6.
6. Positive or negative 6?
Positive.
Positive. So plus 6x to the 4th. Elena, I saw you getting all excited on that last one. Were you just going to go after the like term here? Or did you have something else you wanted to contribute? Okay, I'm just making sure I'm not missing anything. Chloe, quick question. I see x to the 5th here. I see x to the 4th here. Is there anything that has an x to the 3rd?
Yeah.
Which piece?
The negative 9x to the 3rd.
Negative 9x to the 3rd. Does it have a like term anywhere?
No.
No. So I just bring that down, and that becomes part of my final answer, minus 9x to the 3rd. If at all possible, I want to make sure that this is in decreasing order. Makai, you got to put that away from me, or else it's going to have to come up here. I want this written in decreasing order because while it's not wrong if you don't write it in decreasing order, it's bad grammar. We want to practice good grammar. Eric, I have x to the 5th, x to the 4th, x to the 3rd. Are there any x squareds? There is none. So what would I move to if there's no x squareds? 7x and a positive 3x. When I combine those two together, Jaden, what do I get?
Positive. You said positive x.
Nope. I said right here. This is why you need to stay with me.
Oh, 10x. I mean 10x squared. No, just 10x. Just 10x.
Just 10x. Why is it just 10x and not 10x squared?
Because it's not times.
It's not timesing. When I'm adding and subtracting, my exponents don't change. Only my coefficients change. Is there anything else that we need to combine together? Negative 8 and negative 4. What happens when I combine a negative 8 together with a negative 4? Negative 12, so minus 12. So once again, that's the horizontal method. If you want to do this vertically, you can. However, there's something you have to watch out for. Guys, this is the last bit of the lesson, so I really need all eyes up here because this is super important if you're going to choose the vertical method. We have to make sure to line up our like terms. And there's something that your book does that I'm not a huge fan of just because we usually forget. This top polynomial, the first polynomial, I copy down exactly what I see. So I'm going to copy down 2x to the 5th plus 11x to the 4th. Why does your book have 0x cubed right here? Because it doesn't have an x cubed, but what does the other polynomial have? It had an x cubed, so I'm going to line it up so that I make sure that I have a column for each power of x that I've got here. Plus 0x cubed plus 7x minus 8. Your book did not distribute the minus here. I think I find for myself, so that I don't make as many mistakes, I distribute that negative piece so that I'm adding all my columns and I don't forget that I'm subtracting. This way it's exactly the same as when I'm adding my polynomials together. How many x to the 5ths did this have? None. So right underneath this, I'm going to have minus no x to the 5ths. How many x to the 4ths did it have? 5, and I'm subtracting that. So minus 5x to the 4th. How many x cubes? 9, and I'm subtracting that. So minus 9x cubed. Jaden C., help me out. How many just x's did we have? I had 7 here. How many in the other polynomial? Negative 3, but we have to distribute a negative to that. So this turns into what? Turns into plus 3x. And then we have to distribute all the way back here, so I have a negative 4. Now when I go to combine these together, I don't make as many mistakes. Guys, if you don't remember to distribute that negative, I can almost guarantee you'll make a sign mistake somewhere. You'll forget to subtract something. Distribute your negative, add your columns up. 2x to the 5th minus no x to the 5ths. Stays 2x to the 5th. 11x to the fourth minus 5x to the fourth? 6x to the fourth, and it's a positive. 0x cubed minus 9x cubed. Yep, negative 9x cubed. You're absolutely correct, sir. 7x, 3x, 10x. Negative 8 minus 4, negative 12. One last question before I pop your homework up here. Are there any x squareds? Why didn't I make a column for the x squareds? Because there weren't any. Could I have made a column for the x squareds? Yep, it would have been 0x squared minus 0x squared. So I could have made that column, but if I have a 0 in front of a variable, I do not write it down. I do not write that variable with that power down as part of my fully simplified answer. That would be another example of bad math grammar here. All right, do you guys have any questions for me about adding or subtracting? Cool. Your homework is due on Wednesday. You're going to turn it in on McGraw-Hill, but I would recommend getting started on it in your book right now. You can do all but these last 3 problems. The first 4 are exactly like example number 1 that we did. You're going to use those same skills. 5, 7, 9, and 11, these are like examples 2 and 3. You guys need to spend the remainder of our class time, which is about the next 8 minutes, plus some of that D lunchtime. Get those knocked out, and then you only have 3 problems to do tomorrow. Then you're done. All right? I'm available for questions if you have them in any shape or form.